Hello, everyone. For the late start, Mark's out. I had to find the moderator code. Let's see. Okay. I've got noise. Hold on. Let's see. I don't see anything specific on the agenda for today. Did anyone have any topics they wanted to cover while we were all here?
Hi, Sage, it's Nick.
Hey, how's it going?
Yeah, that's about. Sorry, I've been building a new data center the last couple of weeks. So I haven't managed to join the call. I know you've managed to do some work with that sort of deferred write stuff in BlueStore. If I just sort of get the latest master now, is that effectively all in there, and I can sort of do some tests?
Yep.
Okay.
Yep. That should do it. Yeah.
Great. Okay.
Yep.
I'll try and do some tests over the next couple of weeks and just feedback.
Okay. Cool. I think what's there is half decent, but I think we can do better too. So, interesting to hear what you see.
Sure.
Let's see. I can do a quick summary of recent BlueStore pull requests. See the change from Igor that does the reusing blobs and extending blobs that just merged today. That was making a big difference for him. I have a batch going through right now that includes Radoslav's first set of changes to the bitmap allocator that improves the memory utilization and memory layout stuff. That's going through testing now, but that is expected to merge soon. And then the KV sync thread, which originally came from Intel forever ago, and Igor resurrected, and then I cleaned up a bit more. He's doing some additional testing on that, but it looks like it makes a pretty big difference and should go in shortly. Expect. But yeah, he's doing a bit more testing on that first. And then let's see. I think that's it for the main BlueStore stuff. Oh, and there's a pull request that adds a write cache. BlueStore. I'm testing that right now. I'm fixing some bugs. I spilled a 6 terabyte disk up to 90% last night, and so I'm using that to make sure that it's actually behaving in the face of compaction and reads and writes and all the rest. That's uncovering some issues, so dealing with those. But overall, looking pretty good. But I expect that will go in. I think eventually, if RocksDB improves its caching behavior, then we can drop that change. But for now, it should help. Let's see. I think that's mostly it. So the next thing on my list after I do this caching thing and large disk thing is to take the run to completion branch that's been sort of languishing for a while and rebase that on top of the new stuff and get that working. That works really well for when you have like an NVDIMM or very, very fast device for your wall device. Yep, I think that's it for pull requests. Anything else? Any specific topics people want to cover?
2 weeks ago, we were discussing on different both BlueStore optimizations on the very low level, and I just took a quick look at the variant encoding, and I came to the conclusion that we can optimize this a bit without resorting to any crazy assembly code. I made a simple patch for this, and this is what I got from my testing, and I have also prepared a branch for a Git branch for the mark for test it it. Unfortunately, I think he had no time for this, so I think I will just paste it here and see what happens.
Cool. Orange. I got a, yeah, that's better. The first one I got a 404.
Oh, I think
I got spaces in the name or
it
something.
has pasted the wrong link. 1 second. Right. So this ODS chart shows the performance test results on the low level, and as you can see, as the bit width of the value encoded increases, the performance of the original variant encode simply goes down. And what this code was testing is how fast it can encode 10,000 times a single value into 1,000 of buffer list in sequence. So this was a single threaded benchmark. And the time on the y-axis is in seconds. So you can see it's quite constant for new code and increasing in case of old code. And you can see from the code, it's because of the reduced number of calls to the encode function in buffer list.
Awesome.
So this is pretty much a drop-in replacement for existing code, but I was also digging into what we can do else in that regard. In this particular case, we can't optimize decode phase because we simply don't know how many bytes we need to read from the input buffer list. So if we go into extremes, then we can just change the format of the encoding of var-ints and optimize that as well. In what I was checking out is if we can just prepend the actual value by the byte length and just store the interesting bytes of the value in the stream. And this is what I got.
You mean like using the first few bits to indicate how many bytes, something like that?
Sorry, can you say again?
You mean like using the first few bits to indicate how many bytes of data they're going to be?
Something like that.
Okay.
To make things easier, I'm just using entire byte, first byte for this, and remaining bytes are just the value.
Okay.
But
That's
this, of course,
dramatic.
requires, but this requires a format change, so I don't know if it's feasible at this point.
It's more bits too. The overhead is higher.
Actually, it's not that bad. I have just checked it out, and I need to paste it somewhere. 1 second.
Well, while you're finding that, the first change obviously is a no-brainer. We should definitely do that. That's good. Good observation. Good work. I think that the one thing that we should do at the same time is there are like 10 different implementations of various variants of varint in this function, in this header file. And the way that they're written originally, each one is sort of written from scratch. That pull request I had that tried to unroll the loop also rewrote all of the other ones so that they just called a single varint encoding. So they would like, negate it and shift it a bit and then call the main one or whatever it was that whatever trickery they were doing. We probably want to do the same thing so that we don't have to optimize each of these independently, and so the code is simpler and easier to understand.
Yeah.
So if you're up for that, that would be a nice cleanup to do at the same time, and then we can.
Yeah, makes perfect sense. There's one problem though. I don't have any reasonable setup for the BlueStore testing. So what I have proposed here is just based on my limited testing on the low level, and I just made sure that this branch I have linked to is pretty much producing the same results for encode, so it doesn't break anything right from the start.
Yeah, I think that's fine. There's some unit tests for the varant encoding, and if those pass, and if the Ceph object store tool pass, then we can run it through the QA suite. So you don't have to do. And Mark can do some performance checking too, and make sure that it's actually helping in sort of the full environment.
Okay, so do you think I should issue a pull request for this optimized variant code, or just wait for the new encoding and decoding code for variant?
I would. Oh, for the new format, you mean, or for the optimization? Sorry, I missed.
I mean, because this branch optimized variant encode, we can merge it right away. It's just a drop-in replacement. It doesn't replace existing code. It doesn't change the format, so we can include it right away. Or I can make a new code for the new format encoding and just go straight to that. But this will take I think a bit more time.
Let's wait on the new format.
All right.
And just do the optimization, because I think so. If we take just this patch and then also do a cleanup where all the other variants get rewritten in terms of that one, then that'll work without a format change, which we'll need anyway in order to do upgrades. And then even if we switch to the new format, still having everything written in terms of a single encoder and decoder will make any transition like that much easier too.
Yeah, I agree. All right, so the only thing we need to, I think, agree on is whether the overhead of the new encoding is acceptable. I have pasted the link to the results for different values encoded exactly so many times. So you can see for yourself that in one case, we are actually better than the old encoding, and this is an extreme case of a 64-bit number.
Yeah. Yeah.
Otherwise, we are just slightly larger than before.
You're using a full byte to indicate how many following bytes. So if you change that to just be instead of to be like 3 bits, is that enough? That's almost enough.
Probably yes.
Yeah, you could do just 3 bits. Yeah.
Yeah, but the problem is we are having those 3 bits somewhere else standing out, and what I'm doing here is encoding only those 8-bit, only those octets of the value that are actually meaningful. So if there is a 9-bit number, we are storing both 8-bit octets, meaning we are storing actually 16 bits of that value. So it's not doing some bit magic on that.
Yeah, so I would change it so that you shift it so that if you use 3 bits, then you could store up to a 5-bit number in 1 byte, and up to whatever a 13-bit, whatever it's a 13-bit number in 2 bytes. So there'll be a few cases where we get pushed over the edge, and something that used to fit in 1 byte will now fit in 2 bytes. But it shouldn't be too bad, I would think.
Yeah, I think so.
I think the performance is. I mean, the main impact of the larger metadata encoding is actually performance, because the RocksDB metadata is larger, and then there's more compaction and all that.
I know that.
So, but this probably makes up for it, I would think.
Yeah. Anyway, the slowest thing in both functions was calling encode and decode functions. So
yeah. Yep. I think in the case of the new decode code, the new dunk code, you basically just have a pointer. Like you don't have to call decode for every byte. You just have a pointer that you can just walk forward. If I'm not mistaken. Not true. Let me look. It's been a while since I looked at this. In the yeah, the buffer pointer iterator is just a wrapper around a pointer. So you could actually, if you reach into the thing directly, you can just get a car star out of it, and then when you're totally done, you can just tell it how many bytes to advance. So you don't have to call for each byte. Does that make sense?
yeah. The only thing that worries me is that when we have buffer lists with 2 or more buffer pointers pointing to different things, and this pointer isn't, and this buffer list isn't contiguous in memory, so we can't use
So
pointer.
with the deink function, it's always contiguous. That's the big change.
Oh, that's cool.
Yep.
That
So
seems
like if you
exciting.
look at so you'll notice it's a buffer pointer iterator instead of buffer list iterator. And in that case, it's a contiguous piece of memory. So you can just take the pointer, walk forward as far as you want, and then you call get posadd or advance or something. There's a function to call that just moves it forward.
Cool.
Yep. Cool. Okay. Sounds awesome. All right. Any other questions or comments on that? Any other topics anybody wants to cover?
Not from me.
All right. Thanks. That's great. Okay. Well, in that case, this maybe is a short meeting. Oh, I can't think of any other outstanding things that are happening right now. Let me think. Just mention briefly if you're not paying attention to the list, there are a bunch of discussions going on there about improving the crush layouts, and which will improve balance in general, which improves performance. And then there's also the pull request that lets you do explicit mappings to get a perfect balance, sort of post crush. That just merged. So we should be able to look forward to essentially even distributions in Luminous, which will be nice. That'll help. Yeah, I think that's it. All right, short call today. Thanks everyone for joining.
Thanks.
Yeah. Bye-bye.